So in this problem, there's a blue car and a red car, and they're going to be crashed. The blue car is moving 20 meters per second to the right, and the red car is moving 14 meters per second to the left. They're 150 meters apart. The picture is drawn. We have D, V, and T written for each car because it's constant velocity motion. And now we can start the problem. The velocity for the blue car is a positive 20 meters per second because it's going to the right. The red car has a velocity that is negative 14 meters per second, and it's negative because this car is moving to the left. We're going to write an equation for each car, and it's going to be D equals V times T because it's the only equation we have for constant velocity motion. So for the blue car, I get D equals V, which is 20 meters per second, multiplied by time. For the red car's position, or D, is equal to its velocity, negative 14 meters per second, times T. But we have to account for the fact that the red car starts all the way over here, 150 meters from the blue car. So we do that by adding 150 meters to the starting position of the red car. At this point, we have a simultaneous equation. We don't know D, but we want to know when those D's are going to be the same. And when the positions are equal is when they're going to crash. And they both start at the same time, so it's going to take the same amount of time for each car to drive and hit each other. That means that if the position for the blue car is 20t and the position for the red car is negative 14t plus 150, and we know these positions are the same, well, that means that 20 meters per second times t has to equal negative 14 meters per second times t plus 150 meters. From here, we have to do just a little bit of algebra. And what we can do is add the 14 meters per second times t to both sides. By doing this, it's going to get rid of the 14 or negative 14 meters per second t that we have on the right. So now on our left side, 20 meters per second t plus 14 meters per second t gives us 34 meters per second times t. And on the right side, we still have the 150 meters. So now we're going to solve for t by dividing the 34 meters per second. So we divide 34 meters per second on both sides, and that's going to cancel that 34 meters per second out, leaving us with t equals 150 divided by 34, which is 4.41 seconds. From here, we just have to take this time. We can plug back into either one of our starting equations. It does not matter which. We will get the same answer if we do either. I'm going to take this t and I'm going to plug it back in right there for that equation. So that would give me the position of the blue car at the time they collide is its velocity, 20 meters per second, multiplied by how long it has to drive before the two cars crash into each other. So 20 meters per second multiplied by 4.41 tells me that the blue car is going to travel 88.24 meters before it would crash into the red car.